Okay, so let's consider an example of Boyles Law. So we have a gas with an initial volume of 5 liters, 5.0, two significant figures, and an initial pressure of 1.0 atmosphere, again, two significant figures. What volume will this gas occupy if the pressure is increased to 10 atmospheres, right? 2 sig figs, the decimal point indicating that 0 is significant. So we're holding temperature and number of moles constant, so it's really only pressure and volume. So Boyles' law states that P1 times V1 equals P2 times V2. And so in this problem, let's consider the initial volume and initial pressure as given. So we have an initial pressure of 1.0 atmospheres, and we have an initial volume of 5.0 liters, and that's going to equal our final pressure of 10 decimal point atmospheres and a final volume that's unknown. That's our V2. So if we go ahead and calculate the left-hand side, multiply 1.0 atmospheres by 5.0 liters, we get 5.0 liter atmospheres. Notice the units, of course, multiply as well as the numbers. And that's going to equal 10 decimal place atmospheres times V2, our unknown volume. In order to get that volume, we need to isolate V2, so we'll divide each side by 10 decimal point atmospheres. And notice that we'll have the atmosphere unit cancel. So when we divide 5 by 10, we get 0.50, right? 2 sig figs in each of our values so far, so 2 sig figs in our response. The atmosphere's canceled, so we're left in liters, and that equals our final volume. So in Boyles Law examples, we'll be given pressure and volume for one case, and then we'll be solving for either pressure or volume of the other case using the one that's known. So hopefully this makes you a little more confident if you've been struggling with Boyles Law.